Can you see the screen? Okay. Have a look at this for a minute. These are the mechanisms which we have discussed about last time. Okay. So we have discussed that whenever there is a timeout, your transmitter assumes it as a signal of congestion and it reduces the flow, which might not be required in case of wired links. So we have seen split TCP that in case the first part is wired and the next is wireless, we can give them different treatment and have the better efficiency. Do you remember this? So this was one of the TCP variants, which is split TCP. Okay. Now there is something called transitional TCP. So what do we do in usual scenario? In TCP, we are supposed to go for connection establishment. So connection is established by sending SYN segment, then you get SYN plus acknowledgement, you send acknowledgement, then you send the request, you will get the reply, then if the connection is over, so you send the FIN, you get the acknowledgement, or this is the reply, then FIN will be issued by the other party and you send the acknowledgement. So these are the minimum number of segments which will be used even for one transaction. Like if there is just one transaction to be taken place where you are asking for just one query and one request is coming to you. At that point of time, if we follow the conventional TCP or the normal TCP, then this many segments we are going to exchange. So which will be pretty time consuming as well as not efficient in terms of utilizing the bandwidth. So in the transitional TCP, what they are saying, that if you are having request which is just of one segment, then rather than establishing the connection, sending the data and then closing the connection, send the SYN segment, request and FIN together, so that the other party knows that okay, this is the request for connection establishment, the query or the request, and it also indicates finish. That means no more segments are going to come now. So the other party will be saying that okay, I also wanted to establish connection, take acknowledgement, and this is the reply and this is finish from me, and then you send just acknowledgement to that. So in 3 exchanges, our transaction would be over. So if you are having very normal or very small exchange at that time, this can be used. So using normal TCP, it would be taking 9 segments, while here within 3 segments will be done with the job. 3 segments for connection establishment, 3-way handshaking, 1 for the request and reply, and 4 for the connection closing. So now this I don't intend to talk about. This is very generic and much about the common sense, which all of you, if you go through the book, you will understand that which are the performance issues in the network. This is given well in detail. And how do you measure the performance? Which are the measurements for network performance? That is also given. Like first, you should be measuring the relevant parameters. We should do it multiple times so that average will be there. Like if you just measure at one point of time, and at that point of time, if the traffic was at the peak, then you are not bound to get the correct results. If you happen to check the measurement at the convenient time, then it will be very favorable, but again, which is misleading. So take the result over the time and then measure, take the average and then see. Try to understand what is going on. And if at all you are changing something, change one parameter at a time. Do not change 5 parameters at a time. Otherwise, we will not know which one is positively impacting, which one is negatively impacting, and how the effect is there on the performance. So one by one, change the parameter, tune it, observe it, again measure, and so on. So these are some of the issues which some of the measures which they have discussed in the book. And then there are some system designs which can be there for the better performance. Like CPU speed is also important than the network speed. Most of the time when we say that how to improve the network performance, then people will say that okay, improve the bandwidth, but that is not it. Like bandwidth is there, but if you're having 5 routers and routers are slow, then at each router your packet is going to be processed. So CPU speed is also important, and sometimes it could be the bottleneck than the network speed. Then as far as possible, we should be avoiding the tiny segments, reduce the packet count so that your software overhead will be lesser, the processing time will be less. This we already talked about. Like whenever tiny segments were being generated by the transmitter, Nagel's algorithm was used, and silly window syndrome was to be avoided by Clerk's algorithm. Then minimize context switching, minimize copying, you already know this. Then this just you have to keep in mind, like you can purchase more bandwidth, but you cannot lower the delay. Delay is not in our hand. We may spend money on bandwidth, we may have higher bandwidth, but delay is something which is not in your control. Whatever is the propagation delay, that would be there. Not only that, queuing delay will be there, processing delay would be there. So we can go reduce processing delay slightly by improving the CPU speed, but other delay are not in our hand. Then this we already talked about. Avoiding congestion is better than recovering from it. Once you have congestion, packets will be dropped, and if packets are dropped, at that point of time your flow will be reduced, retransmissions will be taking place, so it is not going to result in the better efficiency. So prevention is better than cure is true for congestion. That is why after slow start threshold we enter in the linear rise or congestion avoidance, or it is known as additive increase. That is what we do, so that we are trying to avoid the congestion. Like if there is no traffic jam, that is why we are having the traffic system at the crossroads. We don't wait for traffic to take place and then we try to recover from that. We don't do it. Why do we do it? So that traffic will not be taking place. And avoid timeouts. We know that timeouts are very bad for the network and performance, because we wait for the timeout duration, then congestion window will be reduced, retransmissions, etc. So these are some of the rules which are for the better performance, and we can design our system accordingly. I think these are pretty self-explanatory. Do you have any doubts on this? Is it clear? And these are given at length in the book. You may please read them. Okay. On each of these, I think two pages are there. So if you are interested in knowing details about each one of them, please go through them. Now, this I don't think we'll be talking about. Anyway, I'll just give you a brief about, TCP. I hope you can realize by now that when we talk about internet, laymen or users, they'll be worried about the speed. Okay. When we say speed, then partly that is dependent on the hardware, and partly that is dependent on our protocols, and of course traffic, etc. So when we say hardware, then you can, improve the bandwidth. But after a limit, there will be some restriction to bandwidth as well. And that rule is also true here, that your link is no more stronger than the weakest link. Whatever is the weakest link, that will decide the performance. Similarly, whatever is the bottleneck in your network, like if you are having A, B, C, D, E, your network is like that, and all of them are 10 Mbps, but one of in the between is of 2 Mbps. Then your performance is never going to be more than of 2 Mbps. And to change infrastructure of the entire internet is not in our hand. What I'm trying to tell you is that when we are talking about network speed or network throughput, at that time, of course, bandwidth will matter, but we more rely upon the protocols. If protocols are behaving in a better way, then our performance will be good. Like if we keep on using the original TCP which was there for the wired network, then on each loss or each timeout, like first we will not be having the provision of fast transmission in that scenario. You will be always going for the timeout and congestion window will be reduced to 1, which will hamper the performance adversely. So people have been working on TCP congestion control. That is one of the, if you're talking about networking, there are a few research areas where people have been working from decades. And I think they'll continue to work at least for a few coming years or maybe decades, because there is no limit to the better performance. So one of the area is TCP congestion control, because you know that TCP is the reliable measure protocol of the transport layer, and performance will be decided by the congestion control. Why? Because congestion control estimates the congestion window, which decides the sender's window, and sender's window decides how many packets you're going to send. So eventually, if based on the available bandwidth, if your sender's window is tuned, then the performance will be optimum. Are you with me or have I lost you? Yes. So that is one research area where people have been working. The another research area, of course, at the network layer is routing. People have been working about your routing or routing, whatever you call it. Like if the better routing algorithm, then of course the performance will be improving. And one of the areas is of course security, which you are well aware of. So there are many other side areas as well, but these are some of the mature areas at the network layer routing, at the transport layer congestion control, and at the application layer, they're talking about security. Okay, so there are many TCP variants, and they have, categorized them here. These are just some of them. There are actually plenty of them. Okay, on just, side, there is one TCP variant called New Jersey. Okay, there is one was based on another Peach TCP. There was another name on another city. I forgot right now. So probably one of you will come up in future and come with Nadiad TCP or something. DDU TCP, I don't know what. So there are two major versions which you can remember at the moment. One is cubic TCP and one is composite TCP. Cubic TCP is used in Linux. In most of the Linux systems, they are using cubic TCP. And composite or compound, just a minute. I always get confused in this. Yeah, compound, not composite. Compound TCP is the Microsoft algorithm which they are using in the Windows operating system. By default, in our Windows, it is compound TCP. And cubic TCP is used in Linux. Now, cubic TCP, how does it function? It is very well explained in the research papers. While in compound TCP, there is no transparent details available. They say that they're talking about packet losses as well as delay. I'll briefly talk about this and then I'll leave this topic. Like, see, you can tune your transmitter's window based on two parameters. One could be packet loss. Like all the algorithms which you have seen so far, they function based on the packet loss. That whenever you don't get an acknowledgement, then you go for fast transmission and fast recovery. And then you tune your transmitter's window or congestion window. Or whenever there is a timeout, you tune it. So whenever packet loss is detected or you are suspecting a packet loss, at that point of time, we are doing it. So signal is the packet loss, and then based on the packet loss, our TCP will be functional. One is that. TCP with ECN. ECN is explicit congestion notification. If you remember, I said that whenever router drops a packet, then it will be sending explicit congestion notification, congestion warning. Do you remember that? So yes. So based on that congestion warning, your TCP might be doing it, and that is explicit. Well, these are implicit. Okay, these are not explicit, these are the implicit. And one of them could be read to use. Like they measure the delay. They measure the delay, end-to-end delay. Like end-to-end delay initially was 200 milliseconds. Then it was 200 milliseconds, 201 milliseconds. If your round trip time, they keep measuring. It is something like that. then it is 203 milliseconds, then it is 206 milliseconds. So what does this indicate? This says that your congestion is probably building up somewhere on the network. Queuing delay is taking place, and that is why congestion is taking place, because the time in which I used to get acknowledgement is now increasing, and that is due to either the path has changed, or if there is gradual increase, there is quite possibility that that is because of congestion. So they check end-to-end delay, and then rate can be tuned based on that. That is also they do. And whenever, let us explicit, or they can be packet loss based. So that's it about congestion control of TCP. We are not going to discuss more about it. Feel free to ask me if you have any doubt. Otherwise, we will talk about TCP state diagram. Do we have any doubt in congestion control TCP? How many of you understood basic congestion control of TCP? મારું લેક્ચર છે સરને કે ને કે હું પછી મળું. Huh? Okay, sorry. So, okay, only Prince, Priyank and Keval, they have understood congestion control? Rikin, Abhi? Okay, nice. So see, you will have, okay, tell me, Devansh, everyone. So now we have 2 weeks. I think we have 2 weeks to go, and then your semester is going to end. 2 or 3 weeks, I'm not sure. When is your third internal exam? Or you have had sufficient marks in the first 2 exams that you are, not worried about that. You will just appear in the examination. You will take the examination whenever it is. Anyway, so what I was trying to tell you is that now you would have matured with the subject. And I would ask you to read whichever subject is of your interest, not necessarily this. At least read a few pages of this, okay? You might be very busy with STP, which is nice and which is required as well, because next year, during the campus, how you have performed in STP, how, as in not the marks wise, like how you have implemented it, how clear your concepts are. Okay, 21st March. 21st March. Seriously? So we still have 1, 2, and 3 weeks to go. I thought this was the second week after the sessional exams. Okay, that might be due to that cultural week or something like that. Okay. Philosophic week. Yes. So we'll assign you the philosophic week. You can enjoy at your home and do the celebrations. Can we do it? Can we call off the teaching and just you can have the technical plus cultural festival at your home? Okay. So on a serious note, what I was saying is that STP is important, but it is equally important that you don't let go of reading habit and try to comprehend on your own and try to understand that. So please don't let it go, because scoring marks is very easy and I don't mind it, as long as your concepts are good. If you're fine with that, whatever marks you're getting due to online exams or whichever ways, we all are well aware of, and that is perfectly fine with us. If your concepts are clear and if you get a good job, or you go for the masters which you are looking for, if you are making progress in your career positively, we are fine. But doesn't matter whatever you do, whether you go for job or you go for further study or you go for anything else, reading is something which always you will have to do, because you are in the field in which there will always be innovations and upgradations. So it is not so that once we have learned the formula of cement, it is going to be like that. Even they have innovations, but that is very slow and low paced. So in our field, I seriously urge you to read something daily for 25 minutes, 20 minutes technical, 20 minutes news or newspapers, or I don't know, whatever is of your interest, but please keep reading. And those who have done their schooling in Gujarati medium, please spend 15 minutes daily to speak in English. So we don't want to go for very fancy terms and sophisticated ways to impress the other medium, but whatever you know should be conveyed very fluently to the other person. So again, I'm coming back to this question. If you have no doubt in congestion control, we will move to TCP state transition diagram. Is it fine so far? Great. So now let us talk about this. We know that TCP, have you tried netstat command in the laboratory? NET, STAT, netstat. Have you tried? Did you observe some of the states of TCP? Did you see like listen? Yes. Oh, great. Then it will be very easy for us if you already done it. So now, everyone be with me. The dotted line is used for the server. In this diagram, the dotted line is for the server. The solid lines are for the client. The solid lines are for the client. And the darker line are the normal actions, and the faint ones, like the light ones, they may also take place, but they will not be very frequently taking place. Anyway, dotted are for the server, solid are for the client. And the state name is written here. You know, in the rectangle box, the name of the states are written. And there is one slash, forward slash. Before there is something and there is something after that. So whatever is the before, that is the action, or that is the something which has happened, and this is how you respond to that. Or this is the action which you want to take, and this is how you are responding to it. Like cause and effect. Something like that. So these are the notations. Let us begin. Initially, your server and client, both of them will be in the closed state. The server will be in the closed state and client also will be in the closed state. So usually we want our server to be on 24/7. So let us say once it is in the listen mode, then always it will be in the listening mode. But this is before that, like at once upon a time your server was not running. So that was closed then. Whenever it is ready to take request, then it will be in the listen mode. Whenever it is ready to take the request, it is ready to provide the services, then nothing will happen. It will simply change the state. It is not reacting by sending anything or doing anything. It is simply opening up the port. Like if it is FTP, then on 20, it will be listening. If it is HTTP, then 8080 would be open, something like that. So server will be in the listen state. Now your client was closed. We want to send connect request. So if you want to send connect request, we know that SYN is sent. We already know that SYN is sent whenever we want to send connect request. So we want to send connect request and SYN is sent. What is SYN? Can you tell me what is SYN? When I say SYN is sent, what do you understand by that? Do we write SYN and send to the server? Yes, for connection establishment, that is true. But how do we send connection request? I mean, what do we do? When I say SYN is sent, then what is that? Yes, there is a flag in TCP header, synchronization flag, which is set to 1. Exactly. Yes, yes. So this is a connection establishment request. That particular flag in the header is marked at 1. That's it. And that we are sending to the server. And now the state is changed. Your client is no more in the closed state, but it is SYN sent state because synchronization flag has been set to 1 and it was sent. Now your server, which was in listen mode, it will be receiving this FIN. It will receive the FIN. So the server, is the diagram clear? Can you see it properly? Okay. So the server receives SYN. So we know that your client sends SYN. When server receives that, server is in the other party. Currently, the other party is the server. So it will be sending SYN plus acknowledgement back. It is sending in response to that SYN plus acknowledgement. And it is changing the state to SYN received because SYN has been received. It's changing the state to SYN received. Now this SYN plus acknowledgement, which was generated by the server, it will be received by the client who was waiting here. The client was in SYN sent state. It is receiving SYN plus acknowledgement. So party A has sent SYN, B has received it, and B has sent SYN plus acknowledgement, which is received by A. So A will send acknowledgement to that, and then connection is established. So it is sending acknowledgement and connection is established. SYN received, your server was waiting in that. It is receiving the acknowledgement, and then nothing, like acknowledgements are not acknowledged. Simply your state will be changed. So both of them are in the established state. I believe you have observed established state. Have you? In net state, have you observed established state? Because most of the time your TCP client and server would be in the established state. Because in established state, data transfer will be taking place. Your data transfer state is this one. So you will be sending the query, you will be getting the request. If you get the request, you can send the reply, you will send the acknowledgement. Everything will be taking place in the established state. So that is the normal scenario. Now let us say you have sent SYN. It has sent SYN plus acknowledgement, and something went wrong at this server. It doesn't want to establish connection anymore. Then in the abrupt condition, it will send reset and simply go back to listen. It might issue you reset and it will go back here. At any point of time here, when you are in SYN send, if you receive reset, then what will you do? You will close the connection. So this is not a normal situation, but anyway, that might take place. So now let us go back to the established state. Like your server and client are in the established state. Normally, I repeat, normally your server will never say that I want to close the connection. Client will say, if client wants to close the connection, there is a solid line. That is for the client. If client wants to close the connection, then client will send fin. Fin means finish flag will be marked as 1. And then it will enter in the fin wait 1. Server, which was in the established state, will receive fin. When it receives fin, then it sends acknowledgement to that and it enters into close wait state. This acknowledgement which was generated by the server will be received by the client who is in fin wait 1. Once it gets acknowledgement, it will change the state to fin wait 2. Now, this is known as half closed connection or passive closed connection. Half closed connection. Why half closed? Who will not be able to send data to whom now? After your client is in fin wait 2 and server is in close wait, who will not send data to whom? See, TCP is a bidirectional protocol. So yes, client will not be able to send data now because client has called for finish and server has acknowledged that. So now onwards, your client will not be sending data. So server, if it had some replies to send or whatever, it will be sending that. Whenever client also wants, a server also wants to close the connection, then it will be sending finish. When it wants to close the connection, it will send finish and it enters into last acknowledgement state. This finish which was generated by the server will be received by the client who is in fin wait 2. It receives finish. Once it receives finish, then it already wanted to close the connection. It has got acknowledgement. It is getting finish from the other party. So it will happily issue an acknowledgement and enter in the time wait state. Now this acknowledgement which was generated will be received by the server who was in last acknowledgement state. Once it gets acknowledgement, nothing. It will be closed. Ideally it should not be coming to close. I can say it is going to listen, something like that. If that is iterative process, then it will go in the listen. If there was concurrent process, like most of the servers would be, your child was generated in the listen state. Whenever the request is coming, one child will be generated, it will be assigned this duty, then it will be closed. And time waited is your fourth timer of TCP. There are total 4 timers if you remember in TCP. This is the 4th timer. Which are the first 3? Keep alive timer, retransmission timer, and persistent timer. Nice. So the fourth timer is time weighted timer. Well done. So this is our fourth timer. Okay, we will talk about significance of this after a while. So in time weighted timer, we don't wait for any event except timeout. In time weighted timer, we are starting a timer goes off and we close the connection. So there is a normal flow. Your server, your client wanted to close the connection, send FIN, server receives FIN, sends acknowledgement, this acknowledgement is received. Server wants to close the connection, generates FIN, which is received by the client who sends acknowledgement and then waits in the time wait state. Whenever there is a timeout, it will be closed. Now let us say, if there was a case of simultaneous close, like you wanted to close the connection, you have sent finish. But at that time, the other party also sent you finish simultaneously. Like then in fin wait 1, we are not getting acknowledgement, but we are receiving fin first. Because you have sent finish at the same time, by chance the other party also had generated finish. Then you will get finish. Then what will we do? We will send acknowledgement to that. That okay, we are ready anyway, take the acknowledgement and we are in the closing state. Now the other party will be receiving this finish which we have generated. They will issue an acknowledgement, which acknowledgement will get here. And once we get the acknowledgement, then we will in the time wait state again, the same state, where you are starting a timer. When the timer goes off, connection will be closed. Or this is pretty general. Like if you are sending the finish, the other party, if it doesn't have anything, it will be sending finish and acknowledgement together. That yes, take the acknowledgement, I also want to close. Then you will be sending the acknowledgement and you will enter in the time wait state. Again, timer will be started. Whenever it goes off, connection will be closed. So that's it. Ask me if you have any doubts. Is it clear? And at any point of time, this is not the detailed diagram. Like here, if whenever you want to close the connection abruptly, you can send reset and the other party will be resetting the connection. So this reset can be at any point of time. That if there is abrupt close, then reset and then the connection would be closed. Have you understood this? Like this, all this path will not be followed. One of them will be followed. These are the alternative possibilities. Like you send finish, you get acknowledgement, you get finish, you send acknowledgement, then this path will be followed. If you send finish and you get finish plus acknowledgement together, then this path will be followed. If finish was generated simultaneously, which is pretty rare, but if that happens, then this path will be followed. However, the interesting thing to observe is doesn't matter whichever path you take, but you never close connection before waiting for the timeout. So tell me whether you have any doubts in this state transition diagram of TCP. Okay, so now this time weighted timer, duration of time weighted timer is twice of maximum segment lifetime. Maximum segment lifetime, like if your segment is going to live for 50 milliseconds, then time weighted timer will be on for 100 milliseconds. Whatever is the maximum segment lifetime, twice of that duration is your time weighted timer. And if you see here, whenever timer goes off, we don't do anything actually. We are closing the connection. Then why do you think we are waiting here for a while and then we are closing the connection? Wouldn't it be better if we immediately close the connection here, so that when we close the connection, we are releasing the memory, we are releasing the port address, other connections can use that. So why do you think there is a wait time at the client side before closing the connection? Think over, there are two reasons actually, there are two reasons for this. Can you think over that and tell me that why do you think we have a timer before closing the connection? Anyone? Come on, on, one answer you should be able to tell me. If you look at this diagram carefully, at least one answer some of you should be able to think about. Have you understood the question, what I'm asking? I'm asking that why are we waiting here? What is the significance of time weighted timer? In time wait state, we are starting a timer, fourth timer of TCP, which is time weighted timer. Duration of that is twice of the maximum lifetime. Whenever timer goes off, we are not doing anything, you are simply closing it. So in other words, I can say that we are just waiting here for some time and then we are closing the connection. Isn't it? It isn't so like if there is a timeout, then do this. If there is no timeout, do this. There are no alternative paths here. Like here, there is alternative path. This is to be happened or something like that. While here, there is nothing. So instead of waiting in time waited period, couldn't we directly close the connection? Because earlier we closed the connection, in a way better it is because our resources can be released. Your port address which your client was occupying, that can go in the common pool. The memory, window size which we are occupying for this connection, that can be released and maybe used for other one. Yes, channel, but can you be slightly more specific? You're right. Which packet is dropped? See, not some packets dropped packets, because otherwise it will never. See, here we are coming after doing everything. So other party wanted to close it and it has sent you finish. So we have got the finish. Yes, Devansh, that is true. Not last acknowledgement. Like you have sent finish, the server wanted to close the connection. So server has sent finish segment. We have received finish segment and then we have sent the acknowledgement. Here also we have received finish plus acknowledgement and we have sent the acknowledgement. If this acknowledgement is dropped on the link and directly if we have closed the connection, then what will happen? The other party will keep waiting in last acknowledgement for long duration. Like it is waiting for the acknowledgement, but this acknowledgement is dropped. So what will it do? It will again send finish, but there is no one here. There is no one here. So no one will be responding. So again, there will be a timeout. Again, you will be sending finish. Again, there will be a timeout. Again, there will be a finish. That means server will try for several duration, several number of times, and then it will give up that, okay, probably there is no one, and then connection will be closed. But unnecessarily, server will have to waste some attempts in time. So if we waited for a bit longer here, we could help server close properly if acknowledgement was dropped. Because if acknowledgement was dropped, then here there will be a retransmission timeout. Again, it will be sending finish. So when we are in the time wait state, if we are getting finish, we will send the acknowledgement. So the other party will get this acknowledgement and server will also properly and quickly close. So philanthropists work in a way, we are making sure that the server is also closed properly. It doesn't linger just for waiting for the acknowledgement. Does that make any sense to you? That depends on the server, Keval. Ideally, they shouldn't, information means which information are we talking about, Keval? Acknowledgement data. Yes, ideally transport layer information should not be maintained and it is not even, useful to the server. The transport layer information, the transformator parameters like acknowledgement, data would be given to the application layer. That is the responsibility of the transport layer. This we are talking at the transport layer, right? So if the data is in order and correct, then we will be passing on all the data to the application layer. Now, application layer is supposed to give to the user, and based on that, like if it is FTP, then data would be stored in the FTP, and acknowledgement number, sequence number, port address, etc. should be just removed. That is of no use. But we don't know like how now servers would be implemented, whether they are storing some information source for some purpose or not. That purely depends on the application level implementation, I think. Everyone, did you understand this? That if you're waiting in the time waited period, then you can help to send the acknowledgement again in case that was dropped. Otherwise, your server will keep sending finish segment until it gets tired and then it will give up. Does that make any sense to you? Now, that is not the sole reason. Another reason is, if you remember, I said that, if all the packets are duplicated, like why random sequence number is used initially. Like if your packets are duplicated and they are delivered in sequence, if they are delivered in sequence, then 2 times transaction can be taking place. So rather than going for 0, if you are going for random sequence number, then the acknowledgement which was duplicated will not make any sense and connection will not be established, something like that. So that was one care which we have taken at the transport layer to ensure that no wrong connection is established. Similarly here, this duration is twice of maximum packet lifetime. That means whichever segments are generated by this connection, all the segments will be dead. And then we are closing the connection. We are making sure that all the segments which were generated by this particular connection are discarded. They are no more in the network. Their life is over. And then only we are closing the connection. Why do we do that? As a precautionary measure. Like as the chances are very less that the next connection which are going to establish will have the same sequence number, same port address, everything. But in case if that is so, then also it is not going to harm us, because all the data which was generated by us, lifetime is over, and then we are closing the connection. So no segment of this connection will be treated as valid segments in the next future connections. Do I have you with me? Great. So that's it about TCP state transition diagram. And I think that's it about our transport layer as well. So we have talked about UDP, we have talked about TCP. I want you to read up 2 pages. Will you do it? Will you read 2 pages? There is something called real-time transport protocol. RTP, real-time transport protocol. It is given in the textbook only. So please go through that. What is that? And I want one of you to brief me about it next time in 5 minutes. And then we will talk about something else. Real-time transport protocol. Please read about that. It is something interesting and you will like it. So if we have no doubts, I'll leave you early today. Okay, thank you.